In today's math lesson, we're going to solve a system of equations using elimination. Let's go through some steps to help us solve a system using the elimination strategy. Let's see. The first thing that you will need to do is to make sure that the equations are in the exact same order. Now, what does that mean? Usually, it means that your two equations are in the standard order, the standard format of ax plus by equals c. So if they're both in this format, this whole process will go much easier, much smoother. In your second step, you will need one variable to have the same coefficient in the two equations, but one of them is positive and the other one is negative. For example, if you have a 6x in one equation, then you would need the other equation to have a negative 6x. Or if you had a negative 3y in one equation, then you would need a positive 3y in the other equation. So you are not looking for both of the variables to be the same number. You're just looking for one of them to be the same number. Step 2 is exceptionally important because without it, we cannot do step 3. When you have a variable with the same coefficient, the same number, but one is positive and one is negative, you will then be able to add straight down so that that particular variable is able to cancel out. And then you will solve for the remaining variable. In step 4, you are going to then finally use your answer from step 3 to substitute it back into one of the original equations and then solve for the remaining other variable. Let's go practice. Example 1. We're going to solve using elimination the system of negative 5x plus 6y equals negative 16 and 5x plus 6y equals 4. We start this process by looking for a variable that has the same number, but one is positive and one is negative. So this is an interesting little example to start with. Our y's both have 6's. But they're both positive, so that's not going to work for what we need. Our x's, however, both have 5's, and one is negative while the other is positive. This is exactly what we need. Okay, so our step 2 is our step 3. Now that we have found this, our step 3 is to add straight down. And what that does is it causes the x's to cancel out. And then we add down the other rows with it. 6y plus 6y, well, that makes 12y. Negative 16 plus 4, well, that makes negative 12. And now we can solve. So divide both sides by 12. So y is alone, and y is equal to negative 1. That was the hard part. That was it, the hard part. So let's finish this off. Step 4, we are going to substitute our y value back into one of our original equations. And you truthfully get to pick which equation you want to use. I chose to use the second equation. Why? Well, because they're all positive numbers. And truthfully, most people like working with equations with positive numbers. And that's fine. But either when you chose the top equation or the bottom equation, when you substitute in your negative 1, you should get the exact same answer. So let's go solve for x and see what we get. So 5x plus 6 times negative 1 equaling 4. That gives us 5x minus 6 equals 4, where we add 6 on both sides of the river, and 5x equals 10. Divide by 5, and we find out that x equals an exciting 2. All right, everything that we need to do is done. Let's go write our final answer, where we discover that in our given coordinate point, well, actually our solution coordinate point, truth be told, x always comes first, and that's 2. Y is second, and that's -1. Our final answer is the coordinate point of 2, -1. And there you go. Example 2. We're going to solve the system using elimination, where 2x minus 4y is equal to 18 and -2x plus 3y is equal to -9. So let's start by looking at our equation structure. We see that both of these equations are set up in the standard format. They are in the exact same order of ax plus by equals c. And that's really important, very helpful. Great. The second thing we need to do is to determine if, and hopefully we do, which variable has the same number in front of it, but one is positive and one is negative. Our y's are obviously different. I have a 4 and a 3. My x's, however, are both 2's, which is super, and the top one is positive while the bottom one is negative. This is exactly what we want. So these x's are going to help us out, because in step 3 we saw that when you add straight down, the x's will cancel out because 2 minus 2 is 0. They cancel out. And then we add the other column straight down also. -4 plus 3, well, that's -1. And 18 plus a -9, that's +9. Okay, so let's finish solving for y. We're going to divide both sides by a -1, and y ends up equaling -9. Okay, great. Now we're going to use this information to go ahead and plug it into one of our original equations and solve for x. And I am going to use the top equation. Why? Because I wanted to. You could have chosen either equation. It would be just fine. But regardless of which one you choose, we're going to replace the y value with the -9 that we just found in that solving process. Okay, as a result, there should be an x and only an x in your equation. Let's go solve and simplify. So 2x minus 4 times -9 equals 18. That gives us 2x plus 36 equals 18. After subtracting 36 on both sides of the river, we have 2x equals -18. And to finish it off, we divide by 2, giving us x equals, a -9 also. Isn't that interesting? Okay. We see as a result our final answer, which is always in the order of x and then y, happens to be the coordinate point of -9, -9. And there you go. In example 3, we're going to solve the system using elimination, where x plus 3y equals -12 and 4x plus 3y equals 15. In this particular problem, we see that both of our equations are set up in standard form as ax plus by equals c. So that's good. However, step 2 tells us that we need to find a variable that has the same number in front, but one is positive and one is negative. And no, my x's don't match at all, and that's fine. But my y's only meet half of the requirement. They both have 3's, and that's great, but only one, they're both positive. Neither one is negative. So we have to fix that, and this is how you do it. I need one of these 3's to be negative, and in order to make that happen, you have to multiply the entire equation by a negative. And I am choosing the top equation to work with. Again, you have choices, and you could multiply all of the bottom equation by a -1, but I'm going to do it to the top equation just because. So a negative times positive x becomes a negative x. A negative times a positive 3 becomes a negative 3y. And a negative times a negative 12 makes a positive 12. And then we bring down our second original equation. I haven't adjusted it at all. So we just bring it down. Okay. So now that both of my equations are in ax plus by equals c, and I have my variable y that has the same coefficient of a 3, but one of them is positive and the other is negative, we can go forward and begin solving. So we add straight down, and when we do that, by design, our 3's are now able to cancel. That was on purpose, and that's good. So what happens with our x's? We have negative 1 plus 4. So negative x plus 4x makes 3x equals 12 plus 15. Well, that's going to be 27. Okay? So we've just added straight down. And to finish this off, we'll divide both sides by 3 so that we find that x has a value of 9. All right, we've done the hard work. Let's just finish it off. Okay. So we're going to use this value of x equaling 9 and plugging it back into one of our original equations so that we can go solve for y. And I am going to choose my top equation because it's just more simple. The numbers are smaller and I don't have to multiply anything to the 9. But truthfully, if you chose the second equation, that would be just fine. You'll get the same answer either way. So let's go solve for y. 9 is not being multiplied by anything, so we're going to just subtract it on both sides of the river, giving us 3y equals negative 21. We'll finish this off by dividing by 3 on both sides, and we find out that y equals negative 7. That's pretty nice. So we can finish this now with our final answer, which is always in the order of x and then y, regardless of how you found them, where we have x is 9 and y is negative 7, thus giving us the coordinate point to this solution of 9, negative 7. And there you go. Example 4. We're going to solve the given system by using elimination, where 10x plus 6y equals negative 10 and negative 7x minus 2y equals negative 15. We see quickly that our two equations are both in standard form, which is really helpful. They are ax plus by equals c. Great. So now we need to look at what's going on with the numbers for our variables. X's have a 10 and a negative 7. Well, that's no good. And our y's have a 6 and negative 2. That may be better than you actually realize. Okay. So while these 4 variables, they're just not related in initial appearance. None of them have the exact same coefficient. 10 and 7, there's no quick way to adjust one of those so that they'll both match by multiplication. However, with the y's, we can multiply 2 times 3 to make 6. And then we'll have a positive 6 and a negative 6. So let's do that. Let's multiply our bottom equation by a positive 3. What does that give us? And remember, you distribute all the way through the entire equation. That gives us negative 21x minus 6y equals negative 45. And then our top equation, which we haven't adjusted at all, we're just going to bring it down. So we have 10x plus 6y equals negative 10. All right. So now we're in the same ax plus by equals c order, and our y values have the same have the same coefficient, while one of them is positive and the other is negative, which is exactly what we wanted. We did this on purpose so that when we add straight down, the y's are going to cancel out. And now we can solve for x. Adding straight down, negative 21 plus 10, well, that's negative 11x. And negative 45 minus 10 more is negative 55. Let's divide on both sides of the river with a negative 11, and x equals positive 5. That was the hard work. Now we're ready for the easy work. Let's bring it home. Okay, we're going to substitute this 5 back into one of our original equations. We need to go solve for y. So which equation are you going to use? I decided to use my top equation. Why? Well, 1, because I wanted to, but 2, there's fewer negatives. Not that I'm scared of them, it's just I know that they make most people uncomfortable, and I decided to go with the least traumatic. There you go. Okay, so I replaced the x with the 5 that we found, and let's go solve for y. 10 times 5 is 50, plus 6y equals negative 10. We'll subtract that 50 on both sides of the river, giving us 6y equals negative 10 minus 50 more, which is negative 60. We'll divide by 6 on both sides of the river, and finally y equals negative 10. All right, let's write our final answer. The solution for this system of equations, written in the order of x and then y, is the coordinate point 5, negative 10. And there you go. On our fifth and final example, we're going to solve the given system using elimination, where 4x plus 4y equals negative 8 and 3x plus y equals 14. Okay, our equations are both in the format of ax plus by equals c. But oh no, my x's both have different coefficients and my y's both have different coefficients. So we need to determine which equation we need to multiply by something to make a variable drop out when we add straight down. The easiest option, the least amount of work, is to multiply the bottom equation by a negative 4. Doing this will create a negative 4y when I already have a positive 4y in the other equation. Let's see what our new equation looks like. Negative 4 times positive 3, well, that's negative 12x. Negative 4 times y is negative 4y, equals negative 4 times 14, which is negative 56. We're going to bring down our top equation. We're just going to bring it down. Nothing exciting has happened to it yet. I just need it to be here with the other one. Okay. We see now that while these are in the same ax plus by equals c order, and our y's both have a coefficient of 4, with one of them being negative and the other being positive, which is exactly what we wanted. That was our creation by design. We are now able to add straight down, causing the y's to cancel out. And we see that negative 12x plus 4x makes negative 8x, while negative 56 minus 8 more is negative 64. Dividing by negative 8 on both sides of the river, we get x is equal to positive 8. All right, the hard work is done. Let's go finish this off. So we're going to replace an x in one of our two equations so that we can then solve for y. And I'm going to use the bottom equation. Either equation would have been fine. I just chose the bottom one. So we're plugging in the 8 that we found for x so that we can now go ahead and solve for y. 3 times 8 plus y equals 14. 3 times 8 is 24. 24 plus y equals 14. Subtract 24 on both sides of the river. And y equals 14 minus 24, which is negative 10. Okay, let's go write our final answer and bring this home. Our coordinate point, the solution for this particular system, is going to be the point 8, negative 10. And there you go.